All right, hello everyone. Today we are going to be focusing on how to do dimensional analysis. This is going to be really important when we start stoichiometry in chapter 10, but today we are just using it with more simplified terms so that we can get used to using the conversion factors. So as a reminder, a conversion factor is a fraction that will have an equality, meaning if we have an equality like 0.61 miles equals 1 kilometer, we can put 1 kilometer on one side of the fraction and 0.61 miles on the other side of the fraction in order to cancel out units. So let's start off with our first example, number 1. It says how many miles, so that's what we're looking for, will a person run during a 10-kilometer race? So the number we are given is 10 kilometers, and we are trying to convert kilometers into miles. So in order to do that, I need an equality that relates kilometers to miles. In this case, we do have an equality that has both miles and kilometers. So that is going to be my first conversion factor. So I want to cancel out kilometers, so I'm going to put kilometers in the denominator so that those units cancel out. So 1 kilometer goes in the denominator, and my other side of the equality, 0.61 miles, goes in the numerator. Now you can see that kilometers cancels out, and you're left with your unit that you're looking for, miles. So now we go ahead and multiply that out, and we get 6.1 miles. So that would be our answer for number 1. Next, on number 2, it says the moon is 250,000 miles away. That is what we are starting with. And it says how many feet is it away from Earth? So we are trying to go from miles to feet. So we're going to start with what we have, which is 250,000 miles. Now we want to go from miles to feet. Luckily, we have a conversion factor for that. I want to get rid of the unit miles, so 1 mile is going to go in the denominator, and my 5,280 feet is going to go in the numerator. Now miles are gone. I'm left with feet, which is what it's asking for, and we go ahead and multiply those numbers because 5,280 is in the numerator. When we multiply that out, we get 1,320,000,000 feet. Now, we talked about scientific notation in an earlier lesson, so let's go ahead and put this into scientific notation just for fun. So to put it in scientific notation, we need to take the decimal point and move it to a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we move it 9 times, we get to a number of 1.32. This is a large number, so we're going to have a positive exponent. So it would be times 10 to the 9th feet. And this is our final answer. Now keep in mind, this would also be a sufficient final answer. Just this is another option written in scientific notation. Remember, both of these answers are the same. They are just written differently. All right, and then for number 3, a family pool holds 10,000 gallons of water. How many cubic meters is that? So we are looking for cubic meters. We are given gallons. So we are going to use this conversion here that has both gallons and meters cubed. So starting with what we are given, which is the 10,000 gallons, we are trying to get rid of gallons. So it's going to go on the bottom, 264.2 gallons. And that is equal to 1 meter cubed, or 1 cubic meter. So now our gallon units will cancel out. We are left with meters cubed, which is what we're asking for. And when we do that, we get 378.5 meters cubed. Now, if you had to round this to, let's say, 3 significant figures, you would cut it off after our third significant figure, 1, 2, 3. 5 does in fact round up, so we would get 379 meters cubed for our final answer. All right, number 4 says the average American student is in class 330 minutes for every one day. How many hours per week is this? So let's start with what we have. 330 minutes per, whenever you see per or a division sign, remember whatever is after it is in the denominator. So 330 minutes per one day. Now I'm trying to get to hours per week. So first, let's take minutes and turn it into hours. So we know that in 1 hour, we have 60 minutes. So I know I want minutes to cancel out. So I'm going to put the 60 minutes in the denominator and the 1 hour in the numerator. Now my minutes are gone and I have hours per day. So I have hours, so that's correct. We're going to leave hours alone now. Now I want per week. I know that in 1 week, I have a certain number of days. And this equality is not on here. I apologize for that. But in 1 week, we have 7 days. So if I want to convert days to weeks, I'm going to put 7 days in the numerator so that my days cancel out. And then I'm going to put 1 week in the denominator. So I end up having hours per week as my unit, which is what it's asking for. So now we calculate. So we're starting with 330. Because 60 is in the denominator, we're going to divide. So 330 divided by 60. Press equals in your calculator. And then since 7 is in the numerator, we're going to multiply. So whatever number you got times 7. You should get 38.5 for our answer. And our units are hours per week. Number 5 says, how many seconds are there in 1 year? So we're looking for seconds. We're starting with 1 year. So you always write out 1 year. And now we're trying to get to seconds. Now seconds is really small. Years is really big. So we're going to have to do multiple conversions to get to seconds. The first thing I think of is in 1 year, I have 365 days. So if I want to get rid of years, I'm going to put 1 year in the denominator. So those are gone. And that is equal to 365 days. Now I know that in 1 day, I have 24 hours. So if I want to get rid of day, I'm going to put days in the denominator. And that is equal to 24 hours. Now, for hours, I can go to minutes. In 1 hour, I have 60 minutes. My hours are gone. And now, finally, I know that in 1 minute, I have 60 seconds. So now my minutes are gone, and all of those units are gone except for seconds, which is what we are solving for. So now in our calculator, we'll do 365 times 24. I like to press equals in between just to minimize calculator error. Times 60, then press equals, and then times 60 again. You should get 31,536,000 seconds. Now again, let's practice putting that into scientific notation. Our decimal point is here. 1, 2, 3, 4, 5, 6, 7. Since that is a large number, that will be a positive exponent. So that's going to be 3.15 times 10 to the 7th seconds. Again, both answers are correct. This is just the way that I will typically prefer your answer written as. And I also rounded it to 3 significant figures, which means I counted 3 digits from the left, 1, 2, 3, cut it off. 3 does not round up, so then you just drop those numbers. So if you wanted to write it in its original form, your answer to 3 sig figs is 31,500,000 seconds. So either one of these would work. All right, and then for our example number 6, Lake Michigan holds 1.3 times 10 to the 15th gallons of water. how many liters is this? So I'm looking for liters, and I have gallons. So I'm starting with 1.3 times 10 to the 15th gallons, and I want to go to liters. So again, it's not written here. I'm really sorry about that. But in 1 gallon, it is equal to 3.79 liters. So if I'm trying to get rid of gallons, the 1 gallon is going to go on the bottom, and the 3.79 liters is going to go on the top. So gallons are gone. I'm left with liters. Now I can multiply. So first in my calculator, when I do a question like this, I typically forget about the exponent for now. I do 1.3 times 3.79. I end up with 4.93. And now I can just move this towards the end of the problem. So 10 to the 15th. So I have 4.93 times 10 to the 15th liters. All right, now we're going to ramp it up a little bit to a little more complicated problem sets. Number 8 says Chicago uses 1.2 times 10 to the 9th gallons of water per day. So that is where I'm going to be starting. It says how many gallons per second, so that's what I'm looking for, must be pumped from the lake every second to supply the city. So I know that Chicago uses 1.2 times 10 to the 9th gallons of water for every 1 day. And I want to get how many gallons per second that is. So if I want gallons per second, gallons is not going anywhere. We're going to keep that there. All we're trying to do is convert days to seconds. Well, I know in 1 day, I have 24 hours. I know that in 1 hour, I have 60 minutes. And I know that in 1 minute, I have 60 seconds. So by doing that, because I have day on the bottom and day on the top, they cancel out. I have hours on the top and hours on the bottom, they cancel out. And I have minutes on the top and minutes on the bottom, they cancel out. So now I am left with gallons per second, which is what the question is asking us. So now from here, we can go ahead and calculate. Now there's a few different ways you can do this. After doing this with a lot of students in class, they found it easiest to put this in their calculator as the whole number. So remember 1.2 times 10 to the 9th means that we move that decimal point 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these spots are zeros. So this would technically be 1,200,000,000. So if you want to put that right in your calculator, then divide by 24, then divide by 60, then divide by 60, that might make more sense to you. Like I said in the previous, I do like to keep this for the end. It's just my personal preference. So in my calculator, I'm going to do 1.2 divided by 24, press equals, divide by 60, press equals, and divide by 60 again. I end up getting 0.123413888 repeating. So now I would then apply my 10 to the 9th. So 10 to the 9th is we're making a bigger number, right? So we're going to move this decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. This is another 8. So that means for my final answer, I have 13,889 gallons per second. And remember, you can also answer that in scientific notation if you would rather. So that would be 1.3889 times 10 to the 4th. And that would be gallons per second. And then just to add on to this, if we were doing a certain number of significant figures, let's say we're doing 3, then you would go ahead and round these answers before you circle them. So with 13,889, we would be stopping after this digit with 3 significant figures. 8 would round up, so we would end up having 13,900. And same goes for our scientific notation. 1, 2, 3 digits, and then it does in fact round up. So those would be our final answers. All right, and then for number 9, it says Lake Michigan holds 1.3 times 10 to the 15th gallons of water. If just Chicago removed water from the lake and it never rained again, how many days would the water last? Chicago uses 1.2 times 10 to the 9th gallons of water per day. So this right here is our equality that we're going to use to convert. So we know that 1.2 times 10 to the 9th gallons is equal to 1 day. So we are going to use that in our math. So we're starting with 1.3 times 10 to the 15th gallons. We want to just end up with days. And we know that in 1 day, Chicago uses 1.2 times 10 to the 9th gallons. So our gallons cancel out. If we remember our rule for dividing exponents, we're going to subtract 15 and 9. So 15 minus 9 is going to have 6 left over. So then we can do 1.3 divided by 1.2. That's going to give us 1.08. And again, we have 6 left over. So times 10 to the 6th days. And because it's days, if you really wanted to write this in full notation, it would be 108, 1, 2, 3, 4. So it'd be 1,080,000 days. Again, both of those answers are correct. All right, and our last 2 examples. Number 11 says, if a swimmer swims 85.4 yards in 5 minutes, that's what we're starting with, how many meters will he or she swim in 70 seconds? So we are starting with 85.4 yards for every 5 minutes. We want to go to meters per second. So first, let's convert our yards to meters. We know in 1 yard, it is equal to 0.9144 meters. From this, our yards cancel out. We're left with meters, which we want. And then we need to convert minutes to seconds. I know in 1 minute, I have 60 seconds, so my minutes are canceled out. And now I don't want to know minutes for every 1 second. I want to know minutes for every 70 seconds. So I'm going to multiply this by 70 seconds because that is what it told me in my problem. So now I can go ahead and calculate 85.4 divided by 5, press equals, times 0.9144 because it's in the numerator, divide by 60 because it's in the denominator, press equals, and then multiply by 70. That gives me 18.2 if we're rounding to 3 significant figures. Seconds is gone, so that is just meters. And that is 18.2 meters for every 70 seconds. So that is our final answer. All right, and then we have number 12. I think number 12 was the hardest from this worksheet just because you had to kind of apply it twice. So we know that saffron costs $368 for every 1 ounce of saffron. It wants you to determine how many grams you can purchase for $15. So first, before we figure out how much money we have for a certain number of grams, we have to figure out what is the cost per gram. So we already have dollars. We're just going to go from ounces to grams. I know in 1 ounce, I have 28.3495 grams. And when I do that, I get $12.98 per gram of saffron. So if I'm coming into the store with $15 and I know that for every 1 gram it costs $12.98, that means I can take my 15 divided by 12.98 and that means I can buy 1.1556 grams. And again, if you want to do 3 sig figs, that does round up. Your final answer would be 1.16 grams for that $15.